Welcome to Copernicus Data Space Ecosystem. In this presentation, we will provide a brief introduction to the system, its main components and functionality, and the purpose of its development. The Copernicus program has been a major extension to the amount of open Earth observation data available. This is probably the only objective, global, freely available dataset relevant for the climate crisis. In order to make the best use of this resource, we had to reform the way to access the data. We need it to be accessible in the true sense of the word, so not just freely available without a paywall, but openly, instantly available to everyone, findable with common tools, with processing and analysis also available to those who don't have access to high-performance server infrastructure. We need the results and the raw data to be easy to share and difficult to fake. We are living in times of the global climate, biodiversity, natural resource and society crisis. Satellite imagery are highly relevant for building solutions. We have to start from the images and ground data and create end products that decision makers and regular people are familiar with. So this satellite image, combining radar imagery and true color imagery from the floods near Oxford, may not be familiar to most people, but if based on this we can build an application like a smartphone alarm clock, that would truly introduce change in people's lives. We have to shorten the path from science and exploration to operational applications. In Earth observation, we all know many examples of this in the last decades. Weather monitoring or terrain models used to be experimental scientific applications. Now they are operational things we use every day. We need you, the science and the industry community, to contribute the datasets, the tools, the processing pipelines to build these solutions. And we all need these as fast as possible since we are pressed for time. The main purpose of Copernicus Data Space Ecosystem is, of course, data access. This means downlinking the data from the satellites and storing it in online processing facilities. The big change is that these online processing facilities serve not just to record the data and to store it in its raw format, but also as platforms for cloud processing. Now you can create an analysis product, you can create a small application, such as this mosaic of Stromboli volcano, without actually downloading the data, processing it directly on the cloud. In this example, the orthorectification, the atmospheric correction, the cloud masking of satellite imagery was all taking place inside the data infrastructure, but additionally also the querying, the cutting of the imagery to the area of interest, the selection of the images with the appropriate quality, and the application of this visualization algorithm took place online. So put together, this product, this GIF file, was built without actually downloading the imagery before. Additionally, the insights resulting from the data analysis, the statistical datasets and the data visualizations can also be generated in the cloud. The actual rendering of images or charts or graphs can take place within the ecosystem. This means your computer is just an interface to the processing infrastructure. It's not really a strong dependency for operational analysis. Copernicus Data Space Ecosystem is the system that actually connects the individual components of your data processing pipeline. It's invisible since it's a data infrastructure, but it makes everyday data processing and access possible. At the heart of Copernicus Data Space Ecosystem, Sentinel data is the most important component. Now, all Sentinel data ever collected over land are instantly accessible without a rolling archive. There are additional datasets such as Copernicus contributing missions and complementary Earth observation datasets that are also available in the same infrastructure. Data availability is made possible with APIs. APIs, application programming interfaces, are machine-to-machine interfaces, small pieces of software that allow the code you build to communicate with the code of our backend. This means that you can directly query the datasets you want with the processing done as part of the request. These APIs and the immediate data availability enabled us to build a new browser. Copernicus Browser works in a simple web interface. It runs on any computer or smartphone, and it allows you to directly browse, query, or download imagery or carry out simple analysis operations. Earth observation coding can be difficult. We tried to make this easy by building onboard code repositories that combine popular Earth observation tools with newly built algorithms and notebooks for making it easy to teach and upscale. Cloud computing capacity is available inside the infrastructure, both for public institutions and for commercial entities. Federation and user identity services of the ecosystem enable us to connect to other data spaces to enable interoperability and data sharing. And finally, online code labs and interfaces make building Earth observation pipelines possible without actually setting up a software environment. Put together, this open ecosystem can be a trusted platform for both operational applications for governance and industry applications for the market. This system solves the challenge of data access. It provides instant access to all Sentinel data ever produced. It makes cloud-based processing available to everyone, radically reducing the volume of data transferred. With API access, you don't need to download the individual granules or all the bands in an image. You can only download the product of the analysis that you performed as part of the request. This means that data can be delivered in analysis-ready format, whichever level of processing this means to you. Images, statistics, web map services, or similar. The data processing challenge is also solved. Computing resources are directly connected to the data collections, and your server capacity is not a limitation anymore. Petabyte scale processing is openly available to anyone, subject to the user quota. Upscaling friendly solutions are built in, making the process of experimentation, large area testing, and regional to global scale running very easy to carry through. We have a wide range of code development options for different users. Additionally, the data sharing challenge is also solved. If you want to create an Earth observation product and share it with someone, they don't need to own GIS software or image analysis software. We have an open, intuitive, customizable front end. We have traceability built into the datasets, and that means that it's also possible to build end-user applications on top of this. Copernicus Data Space Ecosystem is continuously evolving. Last year, we mainly worked on setting up the functionality, the individual modules. We still have some tasks to do with releasing a new API, but generally this year is about releasing new datasets. These will include Copernicus contributing mission high-resolution mosaics, but also analysis-ready Sentinel-1 and Sentinel-3 imagery. So put together, Copernicus Data Space Ecosystem is a transformative solution for Earth observation. We believe it is more than the sum of its parts. It allows you to share your datasets and your products to reach a wide range of collaborators. You can create analysis tools and products that you can commercialize or you can open up for open use by anyone on the Earth observation domain. This is the official authoritative IT component of the Copernicus program. Thank you for watching.